$4. One passive ventilation device the size of a dinner plate that sits in your attic and never moves, never needs electricity, never needs maintenance, and never sends you a bill. $4. And this $4 attic device, installed correctly, can permanently eliminate between 40 and 60% of your entire home cooling load. The heat that forces your air conditioning system to run constantly from May through September and generates the $300, $400, sometimes $500 monthly energy bills that American homeowners across the Sun Belt treat as an unavoidable fact of life. The energy efficiency industry charges homeowners between $3,000 and $15,000 for attic remediation systems, spray foam insulation packages, powered attic ventilators, radiant barrier installation crews that address the exact same problem this $4 passive device solves by itself. $4 versus $15,000. The same heat load, the same cooling relief. And the only difference is that one of those solutions requires a contractor with a truck and an invoice pad, and the other one requires a hardware store trip and 45 minutes on a Saturday morning. And I need you to understand what I mean by that specific claim before we go any further. Because the device I am talking about is not new technology. It is not an invention waiting for a patent. It is not something that requires an engineering degree to understand or install. It is a passive attic ridge vent combined with a specific low-E radiant barrier foil configuration that has been understood by thermal engineers and building scientists since the early 20th century. The physics behind it is settled science. The results have been measured and documented in Department of Energy studies, in university building science research, in military construction manuals. The data is not disputed. It is just not advertised. Because you cannot build a $15 billion annual home energy efficiency industry on a $4 hardware store component and 45 minutes of homeowner labor. So the industry buries the cheap solution under complexity, under contractor dependency, under the manufactured belief that your attic heat problem requires professional intervention to solve. This channel is a vault. Every video here pulls one piece of buried knowledge out of the grave that industry money dug for it and hands it directly to you. We have covered wood preservation, leather restoration, pest control, thermal mass climate management, every domain where the cheap solution exists and has been systematically hidden behind expensive branded alternatives. No sponsored content, no affiliate deals with the companies we are exposing. Just the knowledge, straight, no filter, directly into your hands where it belongs. If you want to stop wasting money on industry lies, subscribe and hit the bell. Because the attic secret I'm about to hand you today is one of the highest value pieces of information any American homeowner can possess. And it is going to make you furious that nobody told you sooner. Now let me take you back. Because the physics of this solution was not discovered by a startup. It was not invented by a Silicon Valley engineer with a venture capital budget. It was understood and applied by working people in one of the hottest and most resource-constrained environments in American history. The year is 1932. We are in Phoenix, Arizona. The population of Phoenix at this time is under 60,000 people. There is no grid-connected residential air conditioning. There is no mechanical cooling available to ordinary homeowners. Summer temperatures in the Salt River Valley regularly exceed 115 degrees Fahrenheit for weeks at a time. And the people building homes in this environment, the craftsmen, the contractors, the self-built homeowners of the Depression-era American Southwest, face a problem that is not a comfort issue. It is a survival issue. A home that cannot shed heat becomes a death trap during an Arizona summer. Elderly people die. Children become critically ill. The internal temperature of a poorly ventilated structure in Phoenix in July can exceed the outdoor temperature by 20 to 30 degrees because of radiant heat gain from the roof and the trapped air mass in the attic space above the living areas. The builders of that era, working without power tools, without modern materials, without the budget for anything that was not absolutely necessary, developed a passive thermal management approach for residential construction that combined three elements: a continuous ridge vent running the full length of the roof peak, paired soffit vents along the entire lower roof edge, creating a convective air column that pulled superheated attic air out continuously without any mechanical assistance, and a reflective interior surface on the underside of the roof decking, originally achieved using salvaged tin, flattened cans, sometimes actual aluminum foil in later years as it became available, that reflected radiant heat back toward the roof before it could transfer into the attic air mass. Every farmhouse, every rural home, every structure built before mechanical air conditioning became standard-used passive ventilation and reflective surface management as the primary defense against heat. Keep heat out of the living space by removing it at the source before it transfers. The Phoenix builders of the 1930s simply applied that principle with the specific combination of ridge ventilation and radiant reflection in a way that building science research decades later would confirm was achieving thermal load reductions of between 40 and 65% in the attic space alone. Then mechanical air conditioning arrived. And everything changed. Not because passive thermal management stopped working. It has never stopped working. The physics of convective ventilation and radiant heat reflection is as valid today as it was in 1932. But because mechanical air conditioning created an industry, an enormously profitable industry built on energy consumption, equipment sales, installation contracts, maintenance agreements, and the quiet but powerful financial incentive to ensure that every American home remained thermally dependent on mechanical systems rather than passive ones. The moment you install a system that eliminates 40% of your cooling load passively, permanently, using a $4 hardware store component, you have permanently reduced your energy consumption in a way that no utility company can meter and no HVAC contractor can service. You have removed yourself, partially but significantly, from the grid of manufactured thermal dependency that generates billions of dollars annually for the energy industry and its allied contractor network. And that is exactly why this solution has been buried under 60 years of industry silence, while homeowners across the Sun Belt write monthly energy checks that should be a fraction of what they are. The heat pouring through your ceiling right now is not inevitable. It never was. Let me explain exactly what is happening at the molecular level when attic heat builds up inside your home. Because once you understand the actual physics of how heat moves through your ceiling and into your living space, you will realize that your air conditioning system is not solving your heat problem. It is just fighting it, continuously, expensively, every single day of every summer for as long as you own that house. And a $4 passive device stops the fight before it starts. Heat moves through physical matter in 3 ways. Conduction is heat transferring through direct contact, the way a hot pan heats your hand when you touch it. Convection is heat moving through a fluid or air mass, the way a hot air balloon rises because warm air is less dense than cool air. Radiation is heat transmitting as electromagnetic energy across empty space, the way the sun warms your face even on a cold day through a car window with no physical contact and no air movement involved. Your attic heat problem is primarily a radiation problem, and that distinction is everything. When sunlight hits your roof on a summer afternoon, the roofing material, asphalt shingles in the overwhelming majority of American homes, absorbs that solar radiation and converts it to thermal energy. The surface temperature of a dark asphalt shingle roof on a 95-degree day in Phoenix or Houston or Atlanta reaches between 150 and 190 degrees Fahrenheit. 190 degrees. That superheated roof surface then radiates thermal energy downward into the attic space as infrared radiation, electromagnetic waves traveling at the speed of light across the air gap between your roof decking and your attic floor. This radiant heat transfer happens regardless of insulation. Your R38 fiberglass bats sitting on your attic floor are excellent at slowing conducted and convective heat transfer. They are almost completely irrelevant against radiant heat transfer, because radiation does not need physical contact or air movement to travel. It crosses the air gap in your attic and hits your ceiling insulation directly, heating it from the top down. At the molecular level, what is happening is this. The infrared photons radiating from your superheated roof decking are being absorbed by the cellulose and fiberglass molecules in your attic insulation, exciting those molecules into higher energy vibrational states, which is what heat is at the molecular level, molecular vibration. That vibrational energy conducts downward through your insulation layer, through your ceiling drywall, and into the air mass of your living space below. Your air conditioning system then has to remove that conducted heat energy from your living space air continuously, running its compressor, cycling its refrigerant, consuming electricity, to maintain your target thermostat temperature against a heat source that never stops as long as the sun is up and your roof is hot. The 2 interventions that break this cycle permanently are radiant barrier reflection and convective attic ventilation, and both of them can be achieved with a $4 hardware store component and a correct installation approach. A radiant barrier is simply a surface with low thermal emissivity, meaning a surface that reflects infrared radiation rather than absorbing and re-emitting it. Polished aluminum has an emissivity rating of approximately 0.05. That means it reflects 95% of incident infrared and radiation. And when you install a radiant barrier on the underside of your roof decking between the hot roof surface and your attic airspace, you intercept the infrared radiation before it can heat the attic air mass. The roof decking still gets hot, but 95% of the radiant energy trying to cross into your attic gets reflected back toward the roof instead of radiating downward toward your insulation and ceiling. The Department of Energy's Oak Ridge National Laboratory measured attic temperature reductions of 20 to 30 degrees Fahrenheit in properly radiant barrier-equipped attics versus identical control attics without barriers. 20 to 30 degrees in your attic without a single watt of electricity. Combine that radiant barrier effect with proper convective ventilation, a continuous ridge vent at the roof peak paired with adequate soffit ventilation at the eaves, and you create a passive thermal chimney effect that continuously exhausts whatever residual heated air does build up in the attic space, Hot air rises. It accumulates at the ridge. The ridge vent gives it an exit. Cooler outside air enters through the soffit vents at the lower roof edge, flows up through the attic space, picks up heat, and exits at the ridge, continuously, passively, without electricity, without moving parts, without maintenance, without a service contract. The convective loop runs as long as there is a temperature differential between your attic air and the outside air, meaning it runs all day during the exact hours when your cooling load is highest. The energy efficiency industry knows this. They have always known this. The research is public. The Department of Energy has published it. The Florida Solar Energy Center has documented it. University building science programs teach it. But knowing it and profiting from it are two different things. You cannot sell a homeowner a $15,000 attic remediation package. Once you show them how a $4 ridge vent and $40 of radiant barrier foil accomplishes the same thermal result. So the industry buries the simple solution under technical complexity, under contractor licensing requirements, under the implied message that your attic is a dangerous and complicated environment that requires professional management. It is not. It is a hot box with a physics problem that has a $4 solution. Every year you have paid summer energy bills without the system installed is a year the energy industry correctly calculated you would not figure this out on your own. They were right until today. If you've made it this far, you already know more than 99% of homeowners in America. So here is the exact installation system. Step by step, precise measurements, everything you need to permanently change the thermal performance of your home this weekend. Step 1. Assess your current attic ventilation status. Go into your attic on a clear afternoon between 2 and 4 p.m., the peak solar heat hours. Bring a thermometer, measure your attic air temperature, and write it down. Then walk the perimeter of your attic floor and look up at the underside of your roof decking. You are checking for two things. First, whether you have a continuous ridge vent running along the peak of your roof, visible from inside as a gap or slot running along the highest point of the roof structure. Second, whether you have soffit vents along the lower edge of your roof, visible from outside as perforated strips running along your eave overhangs. If you have both, your convective ventilation path exists and may simply need to be unobstructed. If you are missing either component, that is your first installation priority. Step 2. Clear and verify your soffit vents. The most common and most costly ventilation failure in American attics is blocked soffit vents. Insulation installed incorrectly by contractors or by previous homeowners gets pushed back against the soffit vent openings. Hand seals them completely, destroying the intake side of your convective ventilation loop. Go to each soffit vent location from inside the attic and verify that you can see daylight through the vent opening. If insulation is blocking any vent, push it back and install an inexpensive plastic baffle.